In this video, we're going to talk about ignition modules. Now, once we're past the pilot version of the gas furnaces, which is the older gas furnaces, we start getting into electronic ignition, where there is either a pilot flame that's ignited by an electronic ignition source, or we directly ignite the main burners and on a call for heat. But there's a control module that has to do this. This is called the ignition module. The ignition control module functions as the brains of a gas furnace. It continuously monitors the furnace during startup and operation. The startup sequence begins when the module receives a call for heat from the thermostat. The module activates the combustion blower for approximately 15 seconds. This clears the furnace of any residual combustion gases that might still be in the heat exchanger. It then sends a signal to open the gas valve and ignites the gas. During operation, the module senses the flame by the heat that is generated through the use of a flame rod. When the flame rod is heated, it sends a microamp signal back to the control module, which indicates that the burners are on. If it does not sense the flame, it will shut off the gas valve to prevent any buildup of gas in the furnace. There are two types of ignition modules currently available. We have a non-integrated control module, and we have an integrated control module. A non-integrated ignition control module can open or close a gas valve, control a spark or hot surface igniter, and monitor the interlocks. This type of control is commonly found on older, less efficient furnaces. An integrated ignition control module is a control that uses advanced electronics to provide greater control and functionality than the non-integrated module. This additional functionality includes the ability to perform self-diagnostics. If a problem occurs, the control uses and flashes an LED to indicate a trouble code. Some integrated modules are even able to modulate the flame size. This type of control is usually used in conjunction with electronic thermostats, a variable speed blower, and a modulating gas valve. Burner flame size is regulated based on the temperature difference between the thermostat's set point and the room temperature. The greater the temperature difference, the larger the flame. As room temperature approaches the thermostat set point, the flame size reduces. The ignition control module initially starts the flame between 20 and 50% of its full capacity. As the temperature changes, the flame will adjust to suit the temperature difference. On some modules of modulating furnaces, the ignition module controls the flame modulation based on an algorithm applied to the previous runtime. Some modulating furnaces also use special communicating thermostats that send modulated signals to the ignition module. If a standard programmable thermostat is used with one of these furnaces, it will not work as a modulating furnace. So let's go over the ignition control module functions. Before the heating cycle even begins, different ignition modules require different operational and safety sequences to run. Depending on the furnace design, the function of an ignition module includes some or all of the following operational and safety features: pre-purge, inner purging, post-purging, gas valve operation, pilot valve operation, soft lockout, hard lockout, shut off, trial for ignition, number of ignition attempts. Purging a gas furnace is done by turning on the combustion blower to vent any remaining combustion gases from the heat exchanger. Before the heating cycle begins, an integrated module performs a pre-purge by cycling on the combustion blower to vent out any combustion gases from this heat exchanger. This operation not only vents leftover combustion gases, but it also fills the heat exchanger with fresh air to help prevent any incomplete combustion or misfires. Integrated ignition modules allow the igniter a limited amount of time to ignite the burners. This period of time is called trial for ignition and is usually measured in seconds. The trial for ignition may be chosen from a group of pre-programmed selections. You always want to refer to the manufacturer's service information to properly set this time. Sometimes the ignition system fails to ignite during its trial for ignition. If the time set is exceeded, the ignition module places the furnace in a state of shutoff. This is called lockout. An ignition module with a soft lockout briefly quits trying to ignite for a specific time before attempting ignition again. After a soft lockout waiting period, the system will attempt the whole ignition process again, and this includes a pre-purge. The soft lockout waiting times vary greatly depending on the module being used on a given system and application. During this brief waiting period, the module will often interpurge the system. And interpurging is when the combustion blower cycles on during a soft lockout to vent any combustion gases in the heat exchanger after a failed ignition attempt. Please note that not all ignition modules allow a soft lockout. If a furnace happens to misfire, the control will go into a hard lockout. A hard lockout is a system shutdown for an unspecified amount of time after a furnace fails to light during its trial for ignition, and it will usually require a service call or an interruption of power to the ignition control module in order to reset it. Even after a successful run in the heating mode, the thermostat satisfies and the furnace will go into an off cycle. However, the heat exchanger may still have some combustion gases in it. Some modules will initiate a post-purge cycle in which the combustion blower will remain on for a given time period after the burner operation has ceased. Gas furnaces with pilots typically have shutoff controls. A gas furnace with ignition module that has 100% shutoff closes both the gas valve and the pilot valve when the flame rod does not detect flame. With the advent features such as soft lockout, control modules with 100% shutoff are no longer prevalent as they once were. A gas furnace with an ignition module that has a non-100% shutoff closes the gas valve but not the pilot valve when the flame rod does not sense flame. Furnaces with non-100% shutoff times that are long enough for dangerous amounts of gas to dissipate before attempting to relight the pilot. A gas furnace may have an ignition module with 100% shutoff with continuous retry. With this system, the gas valve and the pilot valve close when the flame rod does not detect flame, but after a waiting period, the control attempts to reignite the pilot. The system cycles between attempting to reignite the pilot and waiting during shutoff pilots until the pilot is lit. Wiring terminal abbreviations for the ignition control module varies with manufacturers. Always refer to an installation manual. However, some commonly used abbreviations for the wiring include the following. GV, MV, or V1 is the main gas valve. PV is the pilot valve. MV/PV is the combined main gas valve and pilot valve. GND, burner ground, and ground burner is the burner ground connection, which is extremely important. 24-volt ground, 25-volt is an unswitched lead off the secondary transformer. 24V, 25V switched leg of the secondary transformer. THW is the thermostat heat signal. Sense or remote sensor is the flame sensor. Spark or ignition coil, spark igniter, a combination spark igniter and flame sensor. FS, flame sensor. IGN would be a hot surface igniter. P1 would be to a vent damper control. PSW would be to a pressure switch. IND would be to a combustion blower. So again, these are just the common labels, but you really do need to refer to the manual that comes with the ignition control. A typical flame sensor will produce a current of anywhere between 1 and 30 microamps. The way to test this is you put your amp meter in series with the flame rod to the burner control. And you should get a decent amperage in there, okay? Someplace between 1 and 30 microamps. Make sure your meter's set for amps, better yet microamps, and make sure you plug your leads into the correct spots on the meter to put your meter in series for an amperage measurement.